In this video, you'll learn how to calculate and simulate your losses and gains using the passive gains breakdown graph within EcoTect. The graph and the tutorial here will allow you to determine which kind of passive factors are creating underheated or overheated periods within your design. I've now opened the EcoTect environment, and we're going to take a look at how we can calculate losses and gains and how we can use the graph to optimize our design. So to show this effectively, I just made up a small model, and the first thing we'll need to check is that the two zones making this building are marked as thermal zones and that they are turned on. The next thing we'll have to ensure is that we get the analysis data out in the right values. So go to user preference, go to localization, and go to energy. I want to have it out in kilowatt hours, but you can have it kind of in all kind of values that you'll need. Say apply this session only. So the next thing we'll have to ensure that we have set up the model with the right materials, because in Denmark and North European countries we have really a large amount of insulations in walls, floors and roofs. So where we get some gains from direct solar is really depending a lot on the orientation and sizing and material properties of the windows. So just to speed this up, to select all windows, go to select by element type, windows, and just choose the right kind of glazing you want to apply. If you go to the material properties here, you'll see that some very important values is the admittance, which is the ability to absorb and give away heat, and the solar heat coefficient, also known as the G value, the visible transmittance, which is a fraction of the color. So let's say we are choosing a very light color, apply to both, and say apply changes, close. You'll now see that we have some very transparent windows, and this also means that we will get a lot of light and heat through the windows. So let's go to the analysis tab and choose passive gains breakdown and just say recalculate. This graph is really a relative graph that will change from whenever we change orientation or changing material properties within the model. But they will show us the relative distribution where we are gaining something from conduction, solar air, direct solar, ventilation, internal heat gain, or interzonal distribution of heat between different zones. So up here, this is where we're gaining something, and right now we have a lot of gains from internal heat because it's very well insulated constructions we're working with, and we have some gains from direct solar and a small amount of gains from solar air because of the molecular heating of our materials. And in the bottom here you will see that we have a relative small amount of conductivity, and we have some ventilation issues here. So let's go to zone settings and look at some of the things that have a lot of impact here. You'll see that the air change rate has been set to very airtight, which is a demand in Denmark, 0.1. But if we change the wind sensitivity to well protected, you'll see that when we recalculate, the graph or the relation changes, not because the losses get bigger, but because the relation between the graphs changing. And that's because EcoTect is really working with wind-dependent infiltration. So let's go to the material properties and say, okay, we want to change these to less transparent windows. Apply color, apply changes, and recalculate. You'll see now we get a smaller amount of direct radiation to our windows, and this was what we were looking for. So really a graph that helps us to determine where does our gains and losses come from, so we're able to interact with the model and our design.